Great. So I've been asked to cover agentic AI, and this is my go-to slide when explaining what we do, and we're going to kind of focus on the right-hand side. We're going to cover two things. We're going to cover how intelligent apps is kind of evolving into this new frontier of agentic AI apps, and then we're going to cover this through the lens of what this really means to the developer. So at the core of intelligent apps lies artificial intelligence, and AI itself is not new. Technologies like kind of machine learning, decision systems, robotics have been evolving for years. And then in the last couple of years, Gen AI has burst onto the scene, and it's unlocking entirely new possibilities. And it's a bit of a game changer. It's expanding AI's potential and redefining what's possible. Now, there's two terms that frequently come up in discussions: AI agents and agentic AI. And I sometimes hear them used in the wrong context. So whilst they sound similar, they refer to distinct concepts. So let's kind of break it down. So an AI agent is a system that performs specific tasks, reacting to inputs and following rules. So an example of this could be a kind of customer service chatbot. It can handle routine queries like, informing the customer of their account balance or paying bills. So these agents, they perform predefined scripts, they provide answers, complete tasks, and they kind of reduce the need for humans. So they are good at managing repetitive, simple tasks efficiently. Agentic AI goes beyond this. It goes beyond following fixed rules. It can think, adapt, and make independent decisions. It's actively learning. It's adjusting its approach to strategies to solve complex problems, and all with minimal human involvement. So Nick, let's think of an example. In scientific research, an agentic AI system could analyze vast data sets, come up with its own hypotheses, and then run experiments to redefine its understanding. And a real-world use case is pharmaceutical companies are using this for drug discovery through kind of molecular stimulation, rapid screening, and analysis. And they're doing this at speed and accuracy that once was considered impossible. So this is making agentic AI much more powerful. It's capable of solving hard problems and driving innovation. And then another term that comes up is multi-agent systems. These are a collection of individual AI agents working together, often collaboratively, to solve complex problems. And it's a little bit akin to microservice-based architectures. You've kind of broke down a complex problem down into smaller units of work. So this modular design allows agents to specialize in specific tasks. So that improves their efficiency, scalability. But then again, like the created microservice-based architectures, there's that challenge of coordination and kind of communication between the different agents. So let's again apply this to another example, in this case, a smart building. So an AI agent could be an example of that could be a smart temperature control. Its job is to keep the turn heat on, turn the heat off, and keep it within a particular range. A multi-agent system could be multiple instances of the temperature controls, but it could also have other kind of types of agents. So maybe managing the air quality, the security, the lighting, the lift maintenance, the water quality, occupancy detection, and they all work together to optimize the building performance. Now remember, agentic AI doesn't just follow preset rules, so it's learning from the building's historic data to spot patterns, and then it adapts in real time to optimize the energy use, the air quality, the carbon footprint, and keep everybody comfortable. So over time, it's predicting and adjusting. It's making predictions and it can adjust itself in advance of any kind of problems arising. When it comes to agentic AI, it's still evolving. The first wave of agents are common today, and they do things like, retrieve information, they ground themselves on data, they kind of reason, they summarize, and they answer questions. They do things like generate content, they take actions when asked. And then it's this second wave of autonomous agents that is the new frontier. It's emerging, and it's where customers' needs are, and it's where our focus is kind of moving to. AI is influencing software development in two ways. It's building software using AI, and it's building AI into software. So the first one, it's building software using AI is things like GitHub Copilot. So it's kind of, it's reducing the developers' think time, it's reducing their keystrokes, and it's providing this learning assistant. But the one we're going to concentrate on is this second case, building AI into software, to enhance its capabilities and just make apps smarter. Intelligence is now the kind of the new baseline for modern apps. So a couple of years ago, we was all talking about modern apps, and we would have conversations like DevOps and cloud native and building resilient code and APIs and integration and reducing technical debt. But now the baseline has changed. Infusing AI into apps to make them smarter. We have to look at responsible AI. That's important. It builds trust. It prevents harm and ensures that technology benefits everybody. But then there's kind of this bit on the left, the developers are key. AI services are very smart and they're clever, but on their own, they're not enough. It's developers that are key. They are needed to build that kind of business logic around these AI services that kind of achieves the goals and builds these agentic applications. Let's look at the high level architecture of an intelligent app. There's kind of three tiers. There's the app itself. There's the front end client. Now that could be a user interface, or it could be another agent, another system. And when it's a UI in Microsoft Talk, we would call that a Copilot. So, Copilot is the UI for AI. Then there's the backend services, and we can put them into kind of two categories. There's kind of AI type services, and then there's non-AI. So an example of a non-AI service might be a weather API or a calendar API. Just going to drill down into those different AI services. So let's look at each one in turn. So a foundation model. A foundation model is an AI system designed to handle tasks by learning from large data sets. So once trained, they can be used with new data to make decisions and generate kind of content. So an example of that is when it's trained on text, these models can understand and generate human language by identifying patterns in words and content and grammar. Two types of models. There's the large language models. They require significant compute resources and run in the cloud. And on the other hand, there's these smaller versions of these models that can run efficiently on devices with less power. And there's some examples at the bottom of kind of foundation models. So AI services include search, and there's kind of two types of search. There's keyword and there's semantic search. Keyword search kind of just looks for exact matches of words, where semantic search can go on and look at the kind of the real kind of meaning and context of. Example there is if we did how does global warming impact nature, a keyword search which just look for global warming or impact, the actual keywords in that query, where semantic search really understands what you're asking for. So it would also provide matches with things like, tell me about rising temperatures harming wildlife. And the technology that kind of handles semantic search is something called embeddings. Let's look at embeddings. We're all used to thinking in kind of 2D and 3D space. We kind of visualize X, Y, and Z axis. But embedding is taking complex data and then converting into vectors with much higher dimensions, sometimes hundreds of thousands of dimensions in one of these vectors. The way to look at this, let's look at an example. So I've got these three sentences. How do I fix my phone screen? And that kind of boils down to a vector, and I've got some numbers there. And then there's a second one that's how do I repair a broken phone screen? Again, it's a string of numbers. And if you look at the numbers, they're quite close. Whereas what is a weather like today, that kind of bears no resemblance. And you can see the vector is very different. In that example on the screen, I'm just showing like 4 numbers in there. In real world, we're talking like something like 1,500 actual numbers to actually define what a sentence means. Another example of embeddings is medical images. What you can do now is take an X-ray and it will convert that X-ray into a string of numbers. But what we start to find is certain conditions in kind of chest X-rays, they kind of cluster together in the same space. So if someone comes along with a new X-ray, you can actually look at the vector and actually work out if there's certain conditions in that image. So a vector store is where you might store these embeddings or representation of data, and there's some examples there. So things like AI search and Redis and Cosmos DB can store these vectors and search against them. Cognitive services, so these are cloud-based APIs that allow developers to put AI into your apps without being experts. So for example, if you want to do translation or you want to do computer picture recognition or hand-drawn faces or speech, you don't have to be an expert on these. You can just call these services, and I've kind of listed the Azure ones there. Okay, let's go back to this diagram, and we've kind of explained what all these different AI services are. When it comes to AI apps, there's several software libraries that you can use, but the Microsoft solution to this is a framework library called the Semantic Kernel. Again, it just reduces the amount of code you need to write when you're developing an intelligent app. Semantic Kernel, it's open source, it's lightweight, extensible. A key thing here, it's fully supported by Microsoft. So if anybody uses this and has an issue, you can contact Microsoft support. Supports these languages, Python, Java, .NET, and it includes these kind of functionality. So it's got connectors to AI services. What it means is that you could, if you want to talk to OpenAI, you can just use this connector. But if next week you want to change your model and use something else, you can just switch the connector to this new model and you don't have to change your application. It's got functionality to help you handle memory, context, prompts. Plugins are the idea that you can extend out to other APIs. If you want to write to a weather API, you could use a plugin. There are plugins out the box for things like, for example, Bing search. Telemetry, you need observability in your app, so there's functionality around that. And then there's two sub-frameworks within Semantic Kernel. Agent framework, which is all about how do you handle multiple agents talking together. And then process framework is the way of defining a process that's event-driven. There is an alternative called AutoGen. You might see us kind of mention that. The difference between Semantic Kernel and AutoGen is Semantic Kernel is fully supported. It's the one that we recommend for enterprises to build their apps. It's supported. There's been those non-breaking changes will be in there. AutoGen is from Microsoft Research. It's intended to be at the leading edge of things. It's there to ideate and to experiment. But if you want to build a kind of an enterprise quality app, you should be using Semantic Kernel. Okay, back to this diagram. We're now showing the Semantic Kernel functionality on it. Want to do is replace that AI services with Azure AI Foundry. So AI Foundry is our complete AI tool chain to give you all these services within a single platform. It's got, all our models that you can design and customize your applications and agents. New service has just appeared, Azure AI Agent Service. This is a place that we can actually host our agents, so it reduces the effort in taking our applications to production. Just to kind of call out, Microsoft has a spectrum of tools for building AI applications. As developers, we're interested on the right-hand side, but there is also these other tools for people to, zero code, low code, to help them create apps. So the left-hand side is like software as a service. The right-hand side is, there's kind of no limits. You're writing code. Just one thing to call out: it's not Copilot Studio versus AI Foundry. There is a lot of interoperability between the two. That's near enough my last slide. I've got a number of examples that if people are interested in this stuff, you can actually try this out. There is some more slides. I've run out of time to do the rest of them, but things like if you want to have an example of taking a document, chunking it into the various vectors and, using Azure Document Intelligence and then storing it in a vector store. There's an example of that. There's an example here of multi-agents. So you've got like a writer agent, an approver agent, an approver, a manager, and how do these agents work together? And then there's another example of a kind of process how to handle a support ticket, and it